we'll go ahead and write that it's equal to K, so rate constant, times the concentration of A raised to the m power times the concentration of B raised to the n power. It turns out that we say m is the order of the reaction with respect to A. Okay? N is the order of reaction with respect to B. M plus N is overall order of the reaction. Okay? This is just getting the vocabulary wrapped around for you so that you can start to think about rate laws. Another important point is that these M and N can be integers, they can be negative, they can be positive numbers, and they can be fractions. You don't know beforehand. The only way you determine this is by going in an experiment. You measure how concentrations change as a function of time. You start to graph that. You can solve analytically. You end up getting your rate constants and so forth. And you can define how the chemistry happens over time in a quantitative way. So point here, overall order is the sum. Cool. Case would be 3. Okay, another aspect of this that can actually get a little bit confusing for you, but if you realize that the units of K can vary. And that, I guess, makes sense if you start thinking about that these concentrations can carry exponents. So you essentially end up varying K such that you end up calculating and getting the right units out at the end of the day. Another important point is that K is dependent the concentrations of the reactants. The initial concentrations of the reactants. So what's neat here, let's just consider a situation when we have a rate that's written equal to K times the concentration of A raised to the m power. And if we have a situation when m is equal to 0, for instance, we say that this is a 0 order reaction and that the rate actually only depends on this rate constant, on K. And so if you doubled the concentration and measured the rate, you would see 4x increase of the rate. And just to show you one last example, if you go ahead, had your exponent equal to m minus 1, this is what's really cool about chemistry. You actually would just say this is a minus 1 order reaction. You would double the concentration, and in this case, you would half the rate. So you just don't know. You got to go in the lab and do the experiment. So this is how people would uncover the order of the chemistry for this simple case of a reaction that's just dependent, in theory, on the concentration of A. Okay, so let's go think about this a little bit more. So for a first order, so now I'm using, you guys should understand what I'm talking about when I say first order reaction. We're going to use